Hey there, everyone. I am Ankur, a student of IIT Roorkee, pursuing my bachelor's in data science and artificial intelligence, currently in my first year. Today I am presenting a code and a PPT I've written for, getting the sum of squares of all the prime numbers to a given number. So, let's start. This program is written in C++, so I hope you know little prerequisites such as the libraries and the loops and the conditions that are inputted in the code. And the conditions and loops are pretty much the same in other languages also, but it's good if you have a grasp on it in this language. So let's go. So, what are prime numbers? You must also ask this question before writing this code. Prime number is a natural number greater than 1 that can be divided exactly only by itself and 1. So we know that 2, 3, 5, 7, 11, 13, 17, 19 are all prime numbers. So what is special about these numbers? These numbers have the prime factors of only 1 and themselves. Like 5 has a prime factor of 1 and 5, 2 has of 1 and 2, 3 is of 1 and 3, and so on. And all non-prime numbers are called composite numbers. And 2 is the only even prime number. All the other primes are odd. So all the other even numbers have the prime factor of 2. So it's only natural that all the other primes would be odd. It should also be noted that 1 is a non-prime number. It is a unique number. So 1 has a prime has is just has a prime factor of 1 itself. And so many people think that 1 should also be included in the prime number. It's not. Um, the prime number by definition should be greater than 1. And 1 is also a unique number and not a prime number because there are many discrepancies with 1. Every positive even number greater than 2 can be expressed as the sum of two prime. So let's think about that. Let's take an example of 8. 8 can be represented as 5 plus 3, in which 5 and 3 are prime. And so can be 12 as a sum of 7 and 5, in which 7 and 5 are primes. Also, each composite number can be factored into prime factors, and individually, all of these are unique in nature. So, uh, let's take an example of 18. 18 can be factorized into 3 into 3 into 2 into 1. 3 and 2 are prime numbers. 1 is a prime factor of each and every number, so 1 is so we don't include it in prime numbers. So 3 and 2 are the only prime factors. So let's go. So the code. The code I have written here is in the ID of VS community. So if you have a different ID or if you write in an online compiler, you should check with the same if some of the commands are the same or you have to change it a bit to, according to your ID or such. So let's go. Well, the first thing I have done is to include the library of IOStream, which gives us the use of cout, cin, and etc. Then I have wrote a line of using namespace standard. This line is very helpful as with this line I don't have to use the word standard again and again with cout, cin, handle, etc. Then I have started a function of int main of data type. Int, of course, int main is just standard name for the function with the data type of int. S- As I have started initiated many variables of int data type. I have initiated many variables a, I, sum of data type unsigned long int. I need not be of the data type of unsigned long int, but I have written in just for the sake of lessening of one line of code. So why unsigned long int? As you know, all the prime numbers are positive integers. So the negative part does not hold any meaning to it. So and long int. Unsigned long int actually gives the user a very big range so that he can input a number. This also helps us as we can calculate the prime numbers up to a very high number. So this is a very helpful thing for us. Then I have just output and printed a few of the lines of the code to make this user friendly one. that are welcome. This program gives the sum of primes and the number up to which one prime numbers in sum, etc. etc. Then the main code starts from the first for loop in which the user inputs the variable a, which is checked with the condition that it should be greater than 2 or equal to 2 every time. Uh, and in such cases, it is decremented, or else the loop is executed completely the and we come out of the loop. So why 2, you say? 2 is the smallest prime number, and we are inputting the variable a such that it is very greater number than 2, and it is decremented every time till it reaches 2. Uh, Till that time, it is checked with another variable v, which I have declared later, so that we can compute every prime number in the range of a and 2. So this range would give us all the prime numbers that we want. And in the net, we come to the nested for loop. In the nested for loop, I have declared another variable of the same data type, unsigned long int, which is initiated to be true because there are many discrepancies with one. It gives the modulo of 0 for every number and etc. And which, takes a very high computation time to compute, and it's not preferred. So unsigned long int, the data type, it's because we also have to reach a. Note that a in the nested for loop is fixed. The decrementation happens in the outside for loop. For the nested for loop, the variable a is fixed, and as it b is incremented every time this for loop is initiated till it reaches a. In this for loop, there are many conditions to be checked. The first condition is if condition that if a modulo b equal to 0. Now, a modulo b is equal to 0 in two of the cases. First case is that a equal to b, and in such case, the number is a prime number. And in second case, that b is a factor of a. Supposedly, take an example of 9. If b is incremented to be 3, then 9 modulo 3 will give out 0. But 9 is not a prime number. So I have tested with another if condition inside the first one that checks that if a is not equal to b, then break out of the loop and check for once again the for condition and increment it, etc. And else condition. The else, of course, stored that the condition of a equals to b. Then, if the a equal to b, then the both of those variables on that spot would carry the value of that particular prime number, which is stored in both of them. Then the variable of sum. Sum variable actually stores the value of sum of squares. So I have stored b into b plus sum. Um, Sum is initialized to be 0, so of course it has to be 0 from the starting because in starting there is no number to calculate the sum from. And then I have see out it. I is just a serial number to check how many prime numbers are there till that number. And then B, and I printed out the what the square of that particular number is. And after the condition is checked, it again runs the for loop till we get each and every prime number in the particular range. And as such, the sum variable is updated each and every time. So at last, the sum variable carries the sum of squares of all the prime numbers in that particular range of a to 2. So at last, we just print the sum of squares of all the prime number in the variable of sum, and we complete our code by return 0 because they were of integer type. So we have to do that. So let's go. So the output. Let's go. So the output screen would look at something like this, that it would show welcome. The program gives us a sum of prime and another number of to which prime number we want in the sum. And supposedly I have put a numbers of 69. So 69 is not a prime number because it has a prime factor of 23 and 3 and 1. So let's decrement it up one by one. 68 is an even number, which again is not a prime. It has 2 as its prime factor. On further decrementation, we get 67, which is a prime number and is rejected by the code. And it's also shows this is the first number below 69, that is a prime and it's square. And so on, it shows many other prime numbers up till 2, which is the 19th prime. So there are total 19 prime numbers in between 2 and 69. Basically, below 69, there are 19 prime numbers. and it also shows their square. At last, it shows the sum of squares of all the prime numbers, which is basically adding this all this given 4, 4, 8, 9, 3, 7, 2, 1, etc. up till 4, which gives us 2, 4, 9, 6, 6. So let's just do one thing and test this code with other test cases and check calculating is true or not, because we should know for sure. So I'll just check with the calculator on my laptop. You can do so with other things or as the calculator you have. So let's go. So there's a video I've put it here of various test cases and other things I've run. So code starts and it asks you to input the input 21. So we are now checking for the prime numbers, the square of prime numbers and the sum. So yeah, 1027 came out to be 1027 there. So yes, we're working for a small number 21. So now let's put a big number like 100. Hmm. So now we can check that we are getting the sum of squares from the calculator 65,796, which is the same value of 65,796 that we get from the code. So yes, the code is running perfectly, but uh, it if you put the value any bigger than like in powers of like Avogadro number 20 10 power 23, then it would of course be out of range. And even with so short a number, I have tried for maximum level 50 lakhs. It code is executed just perfectly, but it takes some time for computation because it has to check each and every time. So yes, it will take some time. Yes, so therefore we are getting that the code works for integer a in the range of unsigned long long int. Of course, it won't work outside the range. Outside the range, it would give a garbage output. Because if we put any value outside the range, like a negative number, for instance, or a very high number would take a lot of competition, and after all that, it would give a garbage value like negative some blah blahs. It would of course not be negative the sum of squares. So yes, it would give a garbage value. So it is not recommended to use it outside the range. But unsigned long long int has a very vast and big range, so your work should be done in this. And this code has a utility which is so important because there is no exact mathematical function to calculate. primes. The sum and squares is just the cherry on top, which computer helps with its computation power. So yes, thank you. That was my PPT and UAC project. If you like the video, you can like it, and if you want to mail me, you can mail me. You can follow me on Twitter, Instagram, and also connect to me on LinkedIn. Thank you.